హలో.
సార్
గుడ్ ఆఫ్టర్నూన్ సార్, బాగున్నారా?
బాగున్నా సార్. సార్ సెషన్ లైవ్కి వెళ్ళింది. సెషన్ లైవ్.
ఓకే.
ఐ విల్ కాల్ యూ సార్ ఆన్ మొబైల్.
ఓకే.
చూస్తామండి ఒక రకమైన నోట్ రాను కదా. ఎప్పుడు మీ ఎప్పుడు ఎప్పుడు అవునా? ఓకే, సరే. డి ఫామ్ మనం చేసుకోవాలి. అయితే ముందు ఆయన వస్తే మనం మార్క్స్ వేసుకుని ప్రిన్సిపల్ చూపించి డివిజన్ టోటల్ వేసుకొని చూపించి, లేదా ముందు రఫ్గా వేసుకొని చూపించిపోద్దాం. ఇప్పుడు ఎలాగ తీసాం కదండి మనం, గ్రేడ్ అని ఎక్స్టర్నల్ గ్రేడ్ అని తీసాం కదా, అందులో వేసుకుని ప్రిన్సిపల్ చూపించి ఓకే అంటే అప్పుడు డివిజన్ దాంట్లో వేసుకుని సరిపోద్దాము. వెంగా మిగిలిపోయిందా? ఇప్పుడు మనం ప్రాజెక్ట్ ఉంది కదమ్మా, దానికి డివిజన్ ఏమి ఇస్తున్నాం? ఫైనల్ గా మార్క్స్ టోటల్ కి అదే ప్రెజెంటేషన్ అని, తర్వాత వైవా అని, ఇంకోటి
హలో మధు గారు. హలో
సార్.
మధు గారు, గుడ్ ఆఫ్టర్నూన్ అండి.
ఆఫ్టర్నూన్ సార్.
వీళ్ళు ఎంతమంది జాయిన్ అయ్యారు సార్? ఏమన్నా
ఒక్క నిమిషం సార్. 18 members as of now.
18 80 సార్?
18 సార్. 19
ఓకే ఓకే
సార్.
అయితే మనం ఈ 3 పెట్టుకుని మనం వేసేద్దామండి. మీటింగ్ కనుక లేకపోతే కూర్చొని వేసేద్దాం, పని అయిపోద్ది. ఇది ఆన్ చేసేసి
ఇది మధు గారు
సార్.
ఇది మనం ఫీడ్బ్యాక్ ఫామ్ ఎంత 4 o'clock ఇద్దామా? ఎట్లా అది ఇచ్చి మనం అంటే 6 లోపల ఇచ్చేట్టుగా చూడండి.
ఓకే సార్, మీకు కాల్ చేస్తా సార్, ఒక్క నిమిషం. అదెవరు ఏం పెట్టారు? ఎవరు తెలియదు. ఇంగ్లీష్
Okay, Madhu garu, shall we start?
Yes, sir. We can start, sir. Guest is also there.
ఎంతమంది జాయిన్ అయ్యారండి?
చూస్తున్నా సార్ 1 second.
సరే.
So 26 as of now, sir.
5 minutes అవుదామా?
ఇష్టం సార్.
అదే సార్, ఒక 5 minutes అవుదాము. జాయిన్ అవుతున్నట్టు కదా సార్.
ఓకే సార్.
అదే Okay, sir. Sir, HOD sir, we'll start, sir. Start చేద్దామా?
Yeah, start చేయండి sir. You can start now.
Okay, sir.
Okay.
So I welcome all the participants for the say day 1 afternoon session. So now for this session, the resource person is K. Sridhar Patnaik, and he is an associate professor in the Department of Madhu garu start చేద్దాం.
Sir, everything is ready, sir.
Okay. He is an associate professor in the Department of Computer Science and Engineering. Oh. Okay, Madhu garu. So we'll start. So welcome all the participants for the day 1 afternoon session. Hello, sir. So now for this session, the resource person is Dr. K. Sridhar Patnaik. He is an associate professor in the Department of Computer Science and Engineering, Birla Institute of Technology, Misra. He has 17 years of teaching and research experience and published many papers in reputed journals and conferences. His current research interest is in software testing, machine learning, IoT, and blockchain. And he's going to deliver a talk on blockchain implementation on IoT, a perspective of security on agricultural data. Okay, sir. Now I request Dr. K. Sridhar Patnaik, sir, to please continue the session. Hello, sir. Dr. K. Sridhar, sir. Please
Hello?
continue the session.
Hello?
Madhu garu.
Sir, I'm audible, sir.
Madhu garu, we can start the session, Andy.
Yes, sir. Yes, sir. Sir is also there. Sridhar sir, you can start.
Please start,
Okay,
sir.
okay.
Start.
I'm audible.
Yes, sir.
My screen is visible, right?
Yes, sir.
Okay. So good afternoon, everyone, and I hope everyone is fine at this pandemic situation. It's quite difficult because as a teacher, we always want that whoever is listening to us should be physically present so that we can interact directly. But in this pandemic situation, we have been forced to work from home. So, but somehow the life should go on, and I hope everyone is fine at their respective homes. Now, I'd like to thank Madhu sir for giving me this opportunity to share some views as far as blockchain and IoT is concerned. So, both are two different entities, and now people are carrying out a lot of research as far as this blockchain is concerned, and they are trying to utilize this concept, decentralized ecosystem on which this blockchain is based on, to different applications, whether it's healthcare, smart cities, or supply chain management, etc. Now, as far as this agriculture perspective is concerned, because it's not restricted to on this particular application as far as agriculture is concerned, it may be applicable to healthcare or smart cities or smart home, smart vehicle, smart grid, wherever you can use, wherever we have Internet of Things, we can use this. Okay. So my voice is clear, right?
Yes, yes, sir.
Okay. So the screen is visible?
Yes, sir.
Okay. Thank you so much. So I don't know how many of you are, because I hope everybody is in the field of teaching itself, and many of you are carrying in research in IoT or a blockchain, but I don't know how many of you are currently working in this area. But I'll just give a general idea, and if some of you are carrying research in IoT, I'll just give a general idea about how, on what basis you will make a decision that you are going to use a blockchain for your IoT system, because the architectures are different, and this IoT devices are quite resource constrained. Their storage and communication capabilities are quite limited. But as far as the blockchain is concerned, they require huge amount of storage and computation capabilities. So there are a lot of huge gap is there. Okay. So let me proceed further. So this is my brief presentation layout. As I mentioned that I'll just give a general idea, because it's very difficult to discuss each and everything in deep as far as IoT and blockchain is concerned. And I assume that many of you might have appeared for hands-on session carried out by Madhu sir, whether it's a IoT boot camp or embedded systems. So I hope that most of the guys from Telangana and Andhra Pradesh they are well versed with this latest current edging test. Latest technologies like IoT and all. So this is my general layout, presentation layout. I'll just give a brief introduction, then various trends like as far as the architecture is concerned, past, present, and future. Then how blockchain becomes a solution for your problems as far as IoT is concerned. Then I'll give a brief introduction to what blockchain actually does, the core components, then the resource requirements, what is required in IoT and what is there in blockchain for us, and how you're going to apply blockchain in IoT. What are the, because as I mentioned in the just now I mentioned that there is a huge gap as far as the resources are concerned. If you are talking about IoT and if you're talking about blockchain, so a lot of challenges are there. So how you are going to come up with such challenges? Then I'll give a brief idea as far as this edge chain is concerned. It's a latest research that is going on, and they have developed some prototypes called edge chain. Okay, that I'll just give a general idea. Then finally, I'll conclude with some conclusion and the references. Okay. Now we all know that the IoT is nothing but connecting things together with the internet. So it has been predicted that the IoT will connect more than 50 billion smart devices by the year 2025. Just imagine how many devices are there. Each and every devices that is present around us will be connected directly to the internet. And during this huge connection, huge amount of data and processing capabilities are required. Okay, so this 50 billion smart devices expect 2025, but maybe 20 billion by the next year itself. Okay. And as I mentioned that a huge amount of devices are connecting, a huge network is created. Now just imagine the scalability. So such trends create significant scalability and security challenges. A huge amount of data is gathered by these sensing devices and they are pushed to the cloud. Then a lot of analytics is done. The question arises here, how you are going to handle that so many billions of devices which are connected to the internet. So that's what scalability is. And then when so many devices are there, then a lot of data is gathered, then the security or the privacy comes into picture. Okay. So first, the devices that are connected, the issues, how you are going to deploy our technology to handle a huge network. Now, if you take a look on the first picture, this is what the earlier days we have this ecosystem as far as several entities are there. They are connected to the mainframe. Okay. So there's something what you call a centralized ecosystem. Okay. For instance, if we talk about Amazon, Google, Flipkart, if I asked you to do some sort of online shopping, obviously you prefer for Amazon and Flipkart, but I asked you to go for abc.com, but you don't go because you don't know what is that site all about. You don't have any trust as such, but you have a trust on this e-commercial sites like Amazon and Flipkart. You directly log into the Amazon and you purchase and you do shopping. So that is something, the past, that centralized environment where or Google or Flipkart, Amazon, they're all totally focused on the centralized ecosystem where our entire data is stored there, because we have trust on those commercial sites or the companies where we are putting a lot of information in those data centers. If anything happens to those data centers, the entire system gets down. Okay. That is something the first picture takes care of. So the second picture is my voice is clear, right? Hello?
Hello, sir, but some noise is coming, sir.
Noise is coming up.
Some background noise is.
What is sir?
Sir.
Sir, they have got some issues, sir.
1 second, sir. You maximize your slide, sir. That is 1 point.
Okay. Done.
Okay, we will mute ourselves, sir. You can.
Okay. So as I mentioned that the first figure focus on the centralized ecosystem, like I have given an example of Amazon, Google and all, they have got their own central repository and we all putting our information on those central repository or the data center. So everything is centralized there. Okay. Now, if you talk about the present situation, the lot of devices, they are also connected to the cloud. So there is also focus on the centralized environment as far as the first environment of mainframe is concerned with the old days mechanism. Okay. And the present situation is that everything is connected to the cloud, whatever the examples that I've cited in the previous case, like Amazon, Google and all, they have all got their own cloud infrastructure, and we are putting our data in those cloud centers. Okay. Because we have trust on these commercial sites like Amazon, Google and all, and our data is put on those data centers. Okay. And they are earning huge amount of billions of dollars based on this present mechanism, centralized mechanism. Okay. Now, what the future trend says? The future trend says that you just remove this servers from the centralized mechanism and connect all these entities in a decentralized fashion, that every node and every connected device will act as a client as well as a server. Each and every participant has got the responsibility to be a part of the entire decentralized ecosystem. And this entire ecosystem works on the phenomena of trusted mechanism. Okay, the trustless mechanism, sorry. So in the first case, in the middle diagram that I've shown, that as far as the cloud is concerned, we're all dependent on the centralized server. But now the future of blockchain, where there is no concept of centralization, everything is decentralized. There is no server at all. Every client acts as a server, and every server will act as a client. So there are three pictures. The past picture focuses on the mainframe. Then the present scenario is that we are totally dependent on our cloud services. And the future is something that there is no central authority as such. Everything is decentralized. Now coming to the solution, because as I mentioned that as far as the blockchain is concerned, the entire phenomena or the mechanism is based on decentralization. There is no central authority as such. So many IoT solutions are still expensive due to the costs related to the deployment and maintenance of these centralized clouds and server farm. Okay. So whatever the infrastructure cost is involved, because I will show in the next slide as far as the architecture is concerned. So these devices that are totally dependent on the central mechanism, as a AWS cloud or a Microsoft Azure cloud, we're all putting data in the central repository. Okay, so many of these IoT solutions are still expensive because a lot of cost is involved while maintaining the centralized servers, cloud servers. And a lot of cost is involved as far as the communication perspective is concerned. So when such an infrastructure is not created by the supplier, then the cost comes from the middleman, something that we are paying. So as I mentioned in the previous slide, the maintenance is one such issue as far as the cost is concerned. So maintenance is also a problem when having to distribute regular software updates to millions of smart devices. As 50 million devices are going to come in the next few years, just imagine as far as from the maintenance point of view, the softwares on which they are working on has to be updated. So a lot of cost is involved in that. Now, if many of you are acquainted with an example as far as Edward Snowden leaks are concerned, the WikiLeaks, hope you are remember this case. It is difficult for the IoT adopters to trust technological partners who in general give device access and control to certain authorities. Most of the government agencies and all who have been given this authentication power to access this information, so there the breach takes place. Okay. So there is a question of information security as such, because the devices access and control to certain authorities like government or government agencies or manufacturers or the service provider, we give them the authentication to collect and analyze the user data. Okay. So that is something that happened with Edward Snowden when we have heard the news of WikiLeaks. Okay. So now the question of privacy comes. So therefore the privacy and anonymity should be at the core of future IoT solutions. We want privacy. So many devices are connected to the cloud. Any malicious attackers can attack these devices. Okay. So the privacy and anonymity should be at the core of our future IoT solutions. Now, the lack of trust is also one of the important aspects as far as by this closed source code is concerned. Okay, because when you talk about decentralized an ecosystem on which the blockchain is based, or the software is open source, anybody can download and use it. Okay, but as far as the current mechanism of centralized server and closed source, they are not open. Everybody can't use. Everybody cannot freely download and use it. So that's why that lack of trust is also fostered by closed source code. And to increase trust and security, what is required is transparency. Everybody should know what is happening in the network. Okay. So that is not possible as far as the centralized cloud system is concerned. So to increase trust and security, the transparency is very important. Let everybody in the network should know what is happening in each and every node. Okay. So that is what we call a distributed ledger system. Okay. So open source approaches should be taken into account when developing the next generation of IoT solutions. When I say the next generation, the entire mechanism is decentralized. There is no central authority. There is no centralized cloud server as such, which acts as a repository or processing mechanism for your IoT devices. Okay, so that's why open source approaches should be taken into account when developing the next generation of the IoT solutions, where everything is decentralized, which is a backbone of a blockchain. Now, let us give a brief idea. I don't know how many of you are acquainted with the basics of the blockchain, but I'll just give a general idea of what a block actually means, okay, as far as the distributed ledger is concerned. For instance, if you are doing some sort of online transaction, you want to send some money to your friend, it doesn't go directly to his friend, your friend's account, rather it goes via bank. And the bank also deducts some amount of transaction amount, okay, because you are dependent on the bank, okay, because you have a complete trust on the bank. Now just imagine that the bank is not there between you and your friend, and you are directly transferring the money. So that is what the current scenario of blockchain says, okay. So in the figure, there are 4 blocks I mentioned. Each and every block is connected to another block through a link called previous hash. Okay, and each and every block has got its own block ID. A nonce is there. Nonce, I'll tell, nonce is nothing but a number for which the miners have to solve a hash puzzle so that they can validate this transaction, and as in turn they can validate the entire block. Okay, so these are the parameters like block, nonce, what are the transactions, the previous hash, and then the current hash. Okay, so each and every block is linked to the previous hash, so that if anybody tries to change any of the information, so it will propagate to the entire network. So that is what you call, you are achieving the concept of immutability. So once a transaction is validated in the block, it cannot be changed. So if you want to change, you can add one more transaction. Okay. So in a distributed ledger environment, each and every node must have the complete ledger. So whatever the change that takes place, each and every participant have an idea of what type of transaction is taking place in the entire network. Now, in order to validate any transaction or a complete block instance, there are different types of consensus mechanisms are there. So there are different miners whose sole responsibility is to mine a particular or to validate a particular block, and for that they have to use some consensus algorithm. For instance, if we talk about Bitcoin, we have proof of work mechanism where the mining nodes must have the full computational power to solve any hash puzzle or to to solve any cryptographic hash puzzle. Okay, because it requires huge amount of computational power to get that particular nonce value. That nonce is nothing but nonce concatenated with your previous hash value plus all transaction. So that complete gets to, maybe if you consider of a star 56, so the value is 256 bit hash value. So that value should be a target value. So if hash of noun concatenated with previous hash and all this transaction that are shown in the black should be less than some target value. So that target value is nothing but your nonce, and the target value is actually very less value as compared to the entire 256 bits of the hash value. So the first few bits can be considered as a part of the solution for which the miners have to validate that block, and that may be starts from some leading zeros, 000 something. Okay, so that value is left, we call it as a difficulty level for the miners. So whichever node has got the capability to solve that hash puzzle, so they are going to validate that particular transaction as well as a block in turn, and they can get a reward as such. Okay, so in Bitcoin they'll get some Bitcoins as rewards because they have used the entire computational power and they have taken so much time to mine that particular block and validate that particular block and put into the blockchain. Okay, so we call it as a miners, and there are different types of consensus algorithms that are used. I'll just give a brief idea in the coming slides. Okay, but there's a general idea is, of the blockchain, that every block has got some block ID, some transactions, and every block is associated with the previous hash of the previous block, so that it is similar to what a linked list appears. Okay, so every block is linked to another block, and that forms the entire chain, and the entire chain is available in each and every node. Okay. So if you talk about in 2008, when this Satoshi Nakamoto has brought this concept of Bitcoin, so it is totally based on cryptocurrency. Okay. So earlier the block reward was 50, then it became 25, then 12.5. Now in the current scenario, whoever is the miner who are mining the block and they are validating the transaction and putting into the blockchain, they are rewarded with 6.25 Bitcoins. So that's the current scenario. And it has been found that around 21 millions of Bitcoins are there, and it is going to exhaust it by 2140. Now, if you Google it, you will find that around 85% of the Bitcoins are already mined. Okay. So there is a current scenario. If you take a look on, if you Google it, the Bitcoin website, you'll find how many Bitcoins are yet left and how many are to be mined. Okay. So this is a general idea about what a block contains and how each block is connected to another block. Okay. So the entire concept of Bitcoin is based on solving the cryptographic hash puzzles, and for that some consensus are there. Okay. So proof of work is one such basic consensus that has been used in Bitcoin. So in Ethereum also we have this proof of work or proof of stake. Okay. So Ethereum is actually a public blockchain. I'll just give a brief idea of that also. So there are two categories as far as the distributed ledger environment is concerned, where there is no central authority as such as we have in the cloud mechanism. So in the public blockchain, every node is connected to every other node. Every node has got the entire set of transactions that are taking place in the entire network, so that they can keep an eye on what type of transactions that are taking place, who are the miners. Okay. So because it takes, in case of Bitcoin, it takes around 10 minutes to mine or to create a new block or to validate a new block. But if we talk about Ethereum, it takes around 12 to 13 seconds to validate any block. Okay. But in Bitcoin, it takes around 10 minutes. It depends on the type of consensus algorithm the miners are going to use. If they mine it at a faster rate, maybe they are taking less than 10 minutes, then the automatically the we have different types of algorithms where the difficulty level will be increased, so that it will take exactly 10 minutes to validate the block. So we have such algorithms, Bitcoin algorithms. So the first picture, it shows a public blockchain where every node is connected to every other node. Okay. But in the next example, next figure, it says a private blockchain where each and every user is an authenticated user. So in such case, the nodes may not be using the proof of work mechanism where they have to use the entire computational power to solve any hash puzzle or cryptographic hash algorithm. Okay. Because everybody is authenticated to use the entire network. So there the consensus algorithm is somewhat different. Okay. As far as the first example is concerned, where each and every participant is open, because you don't know who is there, because everything, the identity is completely hidden. So that's why you call it as pseudo anonymous. Okay, we know the address, but we don't know who are they. So address also in terms of hash address we get. Okay. So that's why this public blockchain, the entire participants or the infrastructure holders or the nodes, they are open. Okay, anybody can be a part of that particular blockchain. But in case of private blockchain, we have authenticated users who are taking the responsibility of handling the entire blockchain ecosystem. Okay. So here I'll show a list. In the vertical section, you see I have listed some of the features as far as the consensus mechanism is concerned. This consensus mechanism is nothing but the algorithms that the miners use to validate any block so that you put into the blockchain. And in the implementation section, I have shown some commonly used blockchains like Hyperledger Fabric, Hyperledger Sawtooth. This Hyperledger is coming from the Linux Foundation. So they're all private blockchains. Then the most famous Bitcoin, where Satoshi Nakamoto has introduced this Bitcoin blockchain based on cryptocurrency. So there you see the consensus method that they use is proof of work. As I mentioned, that proof of work means we have to solve a hash puzzle. So a lot of computational power is required in order to get that hash value, that is nothing but the nouns value, okay, which is nothing but the hash of nouns concatenated with all the transaction, etc., should be less than some target value. Now, in the next column, see Ethereum. Ethereum uses proof of work as well as proof of stake, okay, ET hash or Cashper. So Ethereum is an open source blockchain. I hope many of you are acquainted with this Ethereum. Okay. So it's generally use a Go language. You can download and you can use it. So Coda is also another blockchain that we have. And now comes the most famous for the IoT networks called IOTA. IOTA cryptography. So they generally use Tangle. I'll just give a brief description of Tangle later on. So this IOTA is specifically for IoT networks. And they don't use blockchain as such. They use a different data structure. We call it as a Tangle. It's a DAG or acyclic graph, directed acyclic graph. Okay. So they also use some consensus mechanism, but it's not as tough as Bitcoin or Ethereum. They use some weighting mechanism for that. So the consensus mechanisms, there's a proof of work, proof of stake, or proof of capacity. There are plenty are there that I'll show you in the next slide. So different rows you see. The first one is accessibility, where it's a private or public. Okay. So in public you see Bitcoin, Ethereum, and IOTA. The three are public. And mode of operation, whether it's a permission or permissionless. Permission in the sense means every user is authenticated. Okay, permissionless means they are public, anybody can use it. Now, as far as the decentralized mechanism is concerned, the Hyperledger Fabric or a Sawtooth or other versions of this Hyperledger, so they are partially decentralized, because you know that when I say private blockchain means it's not completely decentralized. Some central authority will be monitoring the activities in the network. But Bitcoin and Ethereum, you see Ethereum, Bitcoin, they are completely open source or works on decentralized mechanism. So as far as Coda and IoT is concerned, they are also partially decentralized. Now, compute intensive. Bitcoin is obviously it use proof of work. A lot of computation power is required, but rest not that much. Okay. Then the most important thing, as I mentioned, the first slide, scalability, because millions of devices are to be connected. A lot of computation power and data is generated and stored in the cloud. So the network size is going to be increased alarmingly. So in that case, you see that Bitcoin, we can increase the size, the scalability is high. Similarly for Ethereum also. And the most important thing is the IOTA, which is specifically designed for IoT networks. So there, the scalability is, you can go for adding many devices because there is no issue as far as scalability is concerned, because it's very high. Scalability, throughput, and latency is very important. So throughput, you see throughput in case of IoT is very high, but as compared to Bitcoin and Ethereum, because they take plenty of time to validate the blocks. Similarly for latency, as I mentioned in my previous slide, that so in case of Bitcoin, in order to mine a particular block or a validated block, it takes 10 minutes. But for Ethereum, it takes 12 to 13 seconds. So the latency in case of IOTA is also 10 milliseconds. You see the time as far as the IOTA is concerned, it goes to milliseconds. Similarly for Hyperledger Fabric also. So immutability, I have already explained. And privacy, you see the privacy as far as IoT is concerned is low as compared to Coda or Hyperledger. And since Bitcoin has introduced the concept of cryptocurrency, so the last row focus on the type of currency that is used. So in some cases they use tokens also. So in Ethereum we use Ether. So one Ether is around 24,000. You can Google it, you can find one Ether is around, maybe, because it keeps on changing. Similarly, for Bitcoin also it is around 7.8 lakhs. So if people are interested, then the wallet, that is because Supreme Court has made it legal as far as the cryptocurrency in India is concerned. And JEPE is JDPY JEPE. You can Google it. JEPE can be used as a wallet for your Bitcoin. So that is most commonly used in India. So in IOTA, specifically for IoT networks, the currency name is IOTA itself. Okay. So there's a different types of consensus mechanism that are very much used in case of blockchain, and different types of blockchains I have mentioned, and what are the features that are responsible for categorizing these different types of consensus mechanism used in different types of blockchains are listed here. Now let us try to compare as far as the architecture is concerned, because as I mentioned in the first slide also, that the most important thing when you want to use a blockchain in IoT, you must be aware of what type of architecture that we have in blockchain and what type of architecture we have in IoT applications. Okay. Now let me brief you about the core important essential aspects or the components of the blockchain. You see at the just the last row, what you call hardware wallet. So because blockchain focus on cryptocurrency itself, if you use IOTA, then we call it as IOTA currency. If you use Ethereum, we use Ether. Bitcoin for Bitcoin blockchain, we use BTC or a Bitcoin. So these wallets, they store your private key. All your coins will be stored in this hardware wallet. So it stores the private. It is mentioned public key, but it's generally in most of the cases it's fine that private keys are stored here in the wallet. And what are the it execute algorithms to generate digital signature, because once you in order to achieve the privacy and secrecy, we use public key cryptography, where your transactions are signed digitally. Okay. So that is also some hash value. So the digital signatures plays an important role, because whatever the transaction it takes place, every transaction gives an assurance of privacy as far as digital signature are concerned. They are also using the hash-256 values. So that is the lowest level is nothing but the wallets where we have got a currency. Okay, so whatever the transaction that we do, each and every transaction has got his own fees. Okay. Just above what you call a middleware, we call it as a light node, in the sense that this light node will allow us to directly access an interface with the main blockchain. Okay. So for instance, you want to verify your account balance, or if you want to verify who are the users are there. So all brief information about the entire blockchain if you want, then this light node plays an important role, because it's an interface or a software where you can, instead of interacting with the entire blockchain, you can just briefly access some information about the different types of transactions that are taking place in the entire blockchain. So that's why this can be used to verify transaction without downloading the entire blockchain. No need to download the entire blockchain, because a light node, you just use an interface software and just interact with the complete blockchain that is there in the above layer. We call it as a full node. So the light node, you can download some information, you want some headers, or you want to verify some some payment you want to verify. Okay. So in that case, you are not supposed to download the entire blockchain software. Rather, you can use some interface. We have different types of interface mechanisms where you can use that to interact with the complete blockchain. And the top layer of this architecture, we call it as a full node, where you have got the installation of the complete full blockchain, whether it's a Ethereum, whether it's a Coda, whatever it is. Okay. So here it validates the transaction and the blocks, because it's a complete blockchain you have, and it strictly follows the consensus mechanisms or the rules of the blockchain framework, which transaction or which types of blocks to be validated based on consensus mechanism. So that's why it maintains the copy of the entire blockchain. So 3 layers we have as far as the blockchain is concerned. I'll show the similar layers are also there in the IoT architecture. So in the blockchain, I've got 3 layers. Similar layers you'll find in IoT also, but there is some difference as far as the resources are concerned. So we have hardware, the wallets where our currency is there. Then we have the middleware, which acts as an interface to interact with the complete full blockchain, which is there in the full node. Now here you see, now this end device, S device, this figure probably it is here. Okay, so I'll just go to the previous slide first. So I hope many of you are well versed with this architecture of IoT, because many of you might be working in IoT as your research work. Now there are 3 layers. We all know that our Raspberry Pi are all sensors, actuators, or power sources. They are all at the lower level. They are all resource constraints. Okay, low bandwidth, low storage, low processing capacity, low power. Everything is low as far as resources are concerned. Okay, their computation capabilities are very less. Storage is very less. So that's why we call it this is an end layer or end device layer. All your Raspberry Pis, Arduino boards, sensors, your wireless technologies, they're all coming in this layer itself. So this is end device, and this end layer you compare with the blockchain layer where we have wallets, okay, where we have got the currencies. Then the middle layer, we call it as edge device layer or a middleware. So nowadays we have a concept of fog computing or edge computing. Okay, so this is that layer, what we call edge, which takes the responsibility of putting the information from the low level to the higher level. So that's why it acts as a gateway. You take the data from the sensing devices, okay, collect them. So the gateways are responsible for that, and then they push into the server or the upper layer called server and a backend layer. So in the middle layer, you'll find all gateways, middleware, real-time analytics, or communication technologies, which acts as a middleware, or we call it as an edge layer or edge device layer. And then comes the top layer where we centralize cloud servers, data storage, the mobile applications. So even if you have a Raspberry Pi in your room and you have connected some sensors and you have got your mobile phone, you cannot directly interact with the Raspberry Pi because the data will go to the cloud through this gateway, and from there it will come to your mobile. So that delay is there. Even the devices are there very close to you, but they all travel to the gateway, then to the cloud, then again comes to the user. So these are the 3 layers, the basic IoT architecture. Okay. So here I have got 3 layers, and in blockchain also I have 3 layers. Now I'll try to compare. Okay. So as far as the resources are concerned, because the resources in case of IoT architecture is very constrained as far as the blockchain is concerned. Now you see the layers that I have shown in the figure, that the first 3 rows with reference, which is actually pointing to our IoT architecture. So there is nothing but Internet of Things. You see the end devices, everything is low. Your processing capability is low, your memory is low, your power, a lot of batteries are used, low power batteries, and the bandwidth is also low because you cannot process a huge amount of data, you cannot transfer a huge amount of data in few seconds. So that's why the edge device is very low as far as the resources are concerned. Similarly, if you talk about hardware wallet in blockchain, there also you see the processing capability or the memory or the power or bandwidth, they are also very low because low amount of currency. Because anybody who have used Ethereum, if they have created their own private blockchain and they're using Web3 technologies, if they put in a test network like Ringbee or Robson, so they might have used that MetaMask as one such wallet. So many of you might be acquainted with this, that MetaMask initially it gives some ethers, maybe 18 or 14 ethers, so that you can create your own blockchain and you can do some sort of transaction, and every transaction will detect some ethers from your wallet. So here also the same thing, the wallet that we use in blockchain. So initially we have few amount of currencies for your test network. Now if you try to compare the edge device and the light node of blockchain, so you see here the CPU power, now slowly we are increasing the levels when you move from lower level to the higher level. Okay, so what you make out from this is there that you can use your IoT infrastructure, or you can employ your blockchain in IoT infrastructure at which level? At the higher level. So higher level where? At the server level, because there my resources are available strongly as compared to the other layers. Okay, you see here server and backend layer of the IoT architecture as well as a full node layer of my blockchain. So the resources are matching here, because otherwise you can't use blockchain as the lower level or the middleware in case of IoT infrastructure until unless you have got that edge computing concept. Okay, that last slide I'll show that edge computing concept. So this how we can compare as far as the layers or the architectural information about both this frameworks are concerned when you talk about IoT or a blockchain. So if you want to use blockchain and IoT, you focus on the cloud layer, because there I have got the resources, I have got the computing resources, I have got the storage resources, I've got the essential bandwidth required for processing the information. So everything is available in that node itself. So we can directly think based on this comparison, you can make it out that I can use blockchain on which particular layer, that above layer where I have got my cloud infrastructure. Now applying blockchain and IoT, as I mentioned that the essential components of the blockchain is, first, the blockchain is always based on the concept of cryptography. So they use this public key cryptography for digital signatures and all. Then I've got the distributed ledger. So whatever the transaction in the form of blocks, so that entire blocks will be placed in each and every node in the blockchain. And then in order to validate the transactions, or in order to prove your entire network from different malicious attacks and all, we have different types of consensus algorithms are there. So three important essentials for blockchain: one is cryptography, another is distributed ledger in a distributed decentralized environment, and then the corresponding algorithms which validate your transaction or the blocks. Okay. Now, in order to achieve these three essentials of the blockchain with reference to the IoT, if you want that a huge amount of devices of an IoT infrastructure that are connected to the cloud, a lot of amount of data is generated by the sensing devices, and you want privacy, then obviously you have to go for blockchain, because if the number of devices are increasing, the number of malicious attackers, they are going to easily attack your end devices. Okay, so in that case, the information or security is lost. So if you want privacy, if you want that each and every device in the network is anonymous, then better go for blockchain. Similarly, you can use, because blockchain is always talks about cryptocurrency, so the money comes into picture, the monetary exchange of data in computer. So for instance, if you're working in a smart cities and smart cities environment, the people are using different types of devices. So you can put some sort of tokens in the form of currencies, that I can use this particular devices. In turn, I should get some reward in a form of some currency or some token, so that each and every individual or the devices can participate in the entire network infrastructure. Similarly, many devices are communicating with themselves. They are generating huge amount of data. So a lot of transactions are taking place. If you want to keep an eye on these transactions that are taking place among these connected devices, so in that case, again, you have to focus on distributed ledger, similar to the ledger that a bank uses. Okay. So, but that is not a distributed one, because everybody can't access that. And the fourth one is smart contracts, because Bitcoin is totally based on cryptocurrency. But when Ethereum came into existence, then they have used a concept of software in Bitcoin. That software in the sense that, for instance, the two parties, because earlier they used to sign some paper contracts. They are signing or purchasing some assets and all. So they used to have some stamped document and all as a contract. But nowadays, people use smart contracts. Everything is digital. Okay. The smart contracts are nothing but the programs or the software where it consists of some policies or the guidelines between the parties who are involved in the distributed environment. Okay. If you want to purchase an house, and if you want to purchase an house, and somebody is going to sell that house, so everybody must have some consensus. So what is the cost? Where is the location? So based on some parameters, their deal will be considered as accepted. Okay. So smart contracts as nothing but a software. In case of Ethereum, we generally use Solidity, and other C++ or even JavaScript is also used. So Solidity is generally used in Ethereum in order to write smart contracts. which helps us to frame conditions and the policies between different stakeholders who want to sign or negotiate some sort of contracts, or maybe some sort of buyer and seller concepts, that if condition is satisfied, the seller will get the amount and the buyer will get the desired assets. Okay. Similarly, as I mentioned, that the IoT devices are resource content devices. So if you want to connect a centralized IoT deployment to a decentralized blockchain network, where the server layer of the IoT deployment acts as the entire point to the blockchain network. So why I mentioned this, right? Because when I compare this layer-wise architecture, only one layer that is visible where I can deploy my entire blockchain into the IoT network, that is nothing but my top layer or the server layer. So that's why it says that connect a centralized IoT deployment to a decentralized blockchain network, where the server layer of the IoT deployment acts as the entire point to the blockchain network. So this is something that we want, that if I'm working in an IoT, if I'm creating any IoT network, I can use a blockchain provided I can have an access to the entire cloud layer. Similarly, the bandwidth requirements. Bandwidth requirements for the IoT devices are very less as compared to the blockchain ecosystem or the environment, because in the blockchain, huge number of transactions are to be processed. So a lot of bandwidth is required as compared to the IoT devices. So that is one restriction or the limitation we have. Similarly, for the security, as I've explained in the previous example, that a lot of devices are connected. So the devices stay connected to the blockchain network for participating in the consensus process. And because they are always connected, so that's why they may be susceptible to some malicious attacks or the security attacks. So if you use blockchain, then you can prevent such type of attacks because of the huge number of devices that are connected to the network. Similarly, latency, as far as the rate at which the data is transferred from one node to another, in case of IoT devices, we want that the latency should be very small, maybe in some milliseconds. But if we talk about latency in case of blockchains like Bitcoin and all, because they try to solve this puzzles or hash puzzles and all, use a lot of computational power. So the latency there is very large as compared to the latency requirement in the IoT infrastructure. Similarly, transaction fee, as I've given an example, that we can use this fee concept in IoT network, similar to what the cryptocurrency does in case of Bitcoin or Ethereum. Okay. So that the data that is generated by these sensing devices can be sold to some government agencies and all based on some fees. Even so that is one fees where you can involve using some smart contracts, or the transaction that takes place from one device to another. There also you use some sort of token system. Okay. So that, for instance, if you talk about this agriculture scenario, there are different types of sensors generally used, like moisture sensor or airflow or a crop sensor or a location sensor or optical sensor or a pH sensors. Every sensor, they gather information, and the information that is actually required for the farmers, that has to be sent to the cloud. The rest has to be removed from that. So we have to write some smart contracts in such a manner, so only some information which is required by the farmers should be sent to the cloud and rest to be removed. Okay. So that is one such example. Similarly, we can use in smart city or smart homes also, we can use this transaction piece. Okay, because a lot of home appliances are connected to your smart energy meter. So every home appliance has got its own threshold. So based on that, you can generate your electricity bill. Then permission versus public. Permission is nothing but something what you call a private blockchain, where all the stakeholders or the nodes, they are authenticated one, they are solely responsible for use that network only. So so that's why you call it as a permission blockchain. And as far as my survey and knowledge is concerned, people are generally going for private or permission blockchain for IoT infrastructure because of security. So there again, so there is some sort of trade-off as far as using blockchain and again going for that private blockchain. So partially it becomes decentralized, not fully decentralized. Okay, because something in a private network is always is always a centralized authorization is there. So we call it as a partial decentralized ecosystem when we talk about this permission blockchain. So public blockchain is open for everyone. Similarly, for physical interface weakness, as far as the cyber physical system is concerned, the devices are very lower level and it is easily attacked by the malicious attackers. So that's what we call as a physical interface weakness with reference to the cyber physical systems. So as I mentioned in the first slide that the people who are working in IoT, people who are doing research in IoT, and there's a big question whether the current trend, the blockchain, because in previous last week only the Prime Minister has focused in his summit, India summit, he mentioned that Internet of Things, blockchain, virtual reality, quantum computing. So the people who are working in IoT, they have to make a decision when to use blockchain. So there is a flowchart. Probably it may not be visible, but I'll just try to read out what it is actually says. First, it says that is it necessary to use a blockchain for my IoT application? So there is a question that everybody who is working in IoT and want to use blockchain, this question must be asked to themselves whether is it necessary to use a blockchain to my IoT application? Next, are there copies of the ledger? If you want that each and every devices, whatever the transaction that is taking place, should be a copy of that transaction should be available in each and every node. If you say yes, then you move further and you ask yourself, are redundant copies needed to be distributed in multiple machines? If you want that whatever the transaction or the blocks are there in each node, you want that copy of that should be available in every node. If yes, then move ahead. Then do all the IoT entities trust each other? So there is also one question because they're trust and trustless. Okay. If it is yes, then go for traditional database. Okay. Otherwise, you ask yourself, would the IoT entities trust a third party? If no, then you go for blockchain. If yes, you refer to any middleman or any government agencies. Okay. So if you don't want trust, go for blockchain. If you want that same copies of the transactions to be available in all the nodes, then go for blockchain. I'll give a simple example of supply chain management system. For instance, in supply chain management system in US also, I'll show some of the examples. What they are doing actually, so the food that we are purchasing, maybe fruits and all. So right from the farmers, right from the manufacturing unit or the farmer side, they pack it and they just send it directly to the warehouse. And then it comes to us maybe by using some sort of transportation. So if you want to monitor the temperature of those foodstuffs that are packed, then you deploy some sensors and then whatever the checkpoints from where that particular foodstuff is moving, right from manufacturing unit to the retailer, then retailer to your shopping mall, from shopping mall to you, there are some nodes are created. So each and every node should contain the data of the information that is recorded by the sensors. So in supply chain management, people are using this, then they are deploying sensors in those food packets and all where the temperature plays an important role. Okay. So they used to monitor the temperature and at each and every level where that food packet is passing from manufacturing unit to the retailer to the warehouse, then the shopping mall, from shopping mall to the local shop. So everywhere they are monitoring the temperature. So that is in a decentralized fashion they are doing it. Otherwise, each and every information is recorded manually somewhere and they'll just enter manually into the database. Okay. So in supply chain management, they are currently using this blockchain infrastructure as far as monitoring each and every food item that is passed from different sections. Okay. So if you want that the same copy of the transaction should be available in every node, then go for Bitcoin. If you want that the nodes or the stakeholders who are involved in the IoT infrastructure, they are trustless. If you don't want to trust them, then go for blockchain. So that's why the last says, are the IoT devices going to be deployed in a restricted network? Now there are two questions, because I know that there is private blockchain and public blockchain. Okay, so you ask yourself whether you want your system to be deployed in a restricted network as a private blockchain only, or open for everyone. If you say no, then is it necessary to control who can update and maintain the blockchain? Okay, so that is the next question. So many questions to be answered before making a decision whether to take blockchain into IoT or not. So is it necessary to control who can update and maintain the blockchain? If it is not, then use public blockchain. No permission is required. If you want that no, some authenticated users should access your IoT infrastructure, then go for public permission blockchain. Okay, so there are two terms are there. Public is also there and permission. Open for all, but some restriction is there. Okay. So if you don't want my infrastructure should be authenticated one, it should be open, then you can go for public blockchain. Otherwise, is it necessary to control who can update and maintain the blockchain? If you say yes, then go for private permission blockchain. If you say no, then go for private permissionless blockchain. Even it is private, you give some authorities to access your information. So that's why, so it'll take some sort of confusion here as far as these partitions are concerned between yes and no. But somehow I'll share this slide so that the people who are working in IoT and want to implement blockchain, because they have to ask themselves these questions. How will you decide whether you're going to use blockchain for your IoT infrastructure or not, whether it is as a part of smart city or in agriculture or smart vehicles or smart grid, wherever it is? You have to ask these questions. If you want the transactions to be replicated in all nodes, if you want that only sole authorities should access your information. So these questions to be asked, and you give answer, and based on that you make a decision whether you are going to deploy a blockchain in an IoT network or not. But one thing is very important as far as scalability and security and privacy is concerned, because these three are very important apart from throughput and latency, that blockchain can be used if you want. And in most of the cases, as far as the literature survey is concerned, they are generally focusing for private blockchains so that the security should be maintained. And as far as the latency in solving the hash puzzles are concerned, they are not, the difficulty level is not that much high as we have in Bitcoin and all. Okay. Because we are focused on private blockchain, so all authenticated user will be there. But obviously we call it as a partially decentralized, because some centralized scheme is observed there. Okay. So these are some of the applications I have listed here from the literature survey. You see everywhere in the first top right hand corner, you see there's farming, it is mentioned, financial transaction, crowd, smart cities, healthcare, smart living, everywhere you'll find this. Okay. So IoT applications with a flavor of Bitcoin to provide to improve the scalability levels, or to improve the performance, or to improve the storage or the computation capabilities with some trade-off. So I hope this table is visible. If not, there are in the different types of consensus algorithms are there, or the methods, because in order to validate the transaction or a block in turn, the nodes or the miners, they have to go through this process of solving some puzzles. Generally we call it as a proof of work in Bitcoin or in Ethereum. So we have different types of consensus mechanisms are there. Okay. So now the question arises, so many have been listed in the literature, right? From proof of work, proof of capacity, proof of elapsed time, proof of stake, and practical budget and fault tolerance, or Stellar, Ripple, Determined, Algorand, and last you see Tangle is mentioned. As I mentioned, this Tangle is nothing but generally used in IoT, in IOTA cryptocurrency for IoT networks. So there they don't use blockchain as such. They use this Tangle, which is called as a DAG or a directed acyclic graph. There we don't have such cryptocurrency mechanism, but there is weightage mechanism is there, but with slight flavor of cryptocurrency. Okay. So what I'll show here, because there are so many mechanisms have been listed here, I'll choose the most prominent one that is applicable for IoT networks. The first one is proof of elapsed time. So proof of elapsed time is most commonly used mechanism when you go for IoT networks. Why? Because its storage and network, its storage, you see here, storage is very high, its throughput is high, scalability high. So that's why whether it's suitable for IoT or not, that is listed in the last column. And you see, which is something completely bold, only 3 mechanisms you will find they are completely bold. It means that these are the 3 mechanisms like proof of elapsed time and practical Byzantine fault tolerance and tangle. These 3 are most commonly suitable for your IoT application. And the rest, they have got some sort of trade-offs or partial implementation. Okay. So because in the column wise, I have mentioned whether it's a private or a public, decentralization with a high, low, medium, scalability, throughput, latency. Okay. So tolerance levels and computing overhead, the processing overhead, network overhead, and storage. So these are the various parameters. Based on that, the researchers have listed the entire list of consensus mechanisms that are used in blockchain. And because you can't use each and everything for your IoT infrastructure, so the most prominent one you can choose, as I mentioned, one is proof of elapsed time and practical Byzantine fault tolerance and tangle. So these 3 can be used without any trade-off because they are fully suitable and people are using it. Okay. So if you want more about this, because I can't discuss everything in detail, so that's why I've listed separately. If I talk about proof of elapsed time, so you can use for private or permissionless or permission blockchain, and they have got high throughput, high scalability, and high storage overhead. So all these 3 are high, so you can use. So whichever IoT infrastructure is satisfying these features, that there are more number of devices are there, a lot of computational capabilities required, and authenticated users can be allowed to access the information of that particular network, then go for this particular consensus mechanism called proof of elapsed time. And similarly, we have various versions of Byzantine fault tolerance. I know many of you are aware of this Byzantine fault tolerance, a very old mechanism started around 80s. Now here this practical Byzantine fault tolerance, this is also one of the important mechanisms you can use for your IoT infrastructure. Here also the storage is very high, your network, your throughput is very high. And the most commonly and specifically made for IoT infrastructure is nothing but your tangle is a part of IOTA cryptocurrency framework. And the tangle is nothing but the directed acyclic graph, because they don't use blockchain as such. They use this data structure, directed acyclic graph. Okay. So the people who are interested in IoT networks using blockchain, they can Google it, Tangle or IOTA. So we have a separate website for that, where you'll find detailed information about how people are using this IoT cryptocurrency concept in case of IoT networks. So when I say the throughput or the rate at which the data packets are passing, or the bit rate, so here around 1000, more than 1000 transactions per second that are taking place, then also I can say that the throughput is high. So the benchmark that has been set by the researchers, so as far as high throughput is what, similarly latency means maybe 10 milliseconds or less than that. Okay. Because we can't wait for latency of 10 minutes as it takes in Bitcoin in order to mine a particular block. And so there is a current project that is going on, and so this is a recently published article in IEEE Transaction and Internet of Things. The most new and novice innovation as far as using Bitcoin, blockchain in IoT infrastructure. So what prototype they have, because the work is still going on. So they have given or developed a prototype where whatever the computational or storage capabilities that are available at the top layer or the cloud server layer, you reduce that and bring it to the middle layer. So we call it as similar to what we have fog computing or edge computing, where the computational capabilities are brought near to the IoT devices or the edge devices or the edge layer, end layer, the lowest layer where I have got my IoT devices. So that's why you call it as an edge tier or edge chain. So you create different types of blockchains. We call it as I've shown, this is one, edge node 2. So plenty of edge nodes are there. So different blockchains are applied at the middle layer itself. So that's why we call it as an edge chain. You create a chain of blocks at the middle level itself, around the gateway itself, so that everything will be reduced now, because the delay, the bandwidth, the data processing, everything will be reduced to some extent because you have reduced the distance now. Okay. So that's why here also we have 3 layers: the cloud layer, the edge layer, where some half of the portion has brought to this middle layer, so that it will take less time. At the lower level, I have got the IoT devices. So these IoT devices, and each and every IoT devices form a group. So you see there is a first group, second group, and third group. So we have plenty of such groups. So depending on the application, you can create some slots. Okay, so they have created some slots, and they have created a particular block of chains that are taking place as far as communication between the edge devices to this edge layer and then to the cloud architecture. So this is what it looks like. So as I mentioned, the scalability and the security are quite important. And the edge chain, where you are creating several blockchains at the middle layer, and every blockchain is restricted to the corresponding IoT infrastructure, as I've shown, the IoT devices. Okay. So in this way, they have created a prototype, and they call it as an edge chain. And still the work is going on, because it's not completely proof now, because the work is going on, and they have proposed this mechanism that instead of doing the computations and all at the cloud level, you can reduce and bring it to the gateway near to the IoT infrastructure, so that it will take less time for communication and the processing as well. So as I mentioned that some of the case studies that are available where people have used blockchain in IoT infrastructure, the most commonly used is Helium. Helium is a project, is a first decentralized machine network, and the company uses this blockchain to connect this low power IoT devices like routers, microchips to the internet. Similarly, Chronicle also combines blockchain and IoT products to deliver end-to-end supply chain solution. One example, food example that I've given, how the food packets that are coming from different the resource to different sources, like from retailers to the from retailers to the shopping malls. So they are creating a chain, and that food packets are creating a network and moving from one point to another. In every point, they are monitoring the temperature. Okay. So that's why they have used this, that concept they have used, called supply chain solution, where they have employed a private blockchain in an IoT infrastructure. Similarly, for medicines, also focusing on the pharmaceutical and food supply industries, they use IoT enabled shipping containers. So sensing devices they have attached to this medicines or the food containers to monitor the temperature at different locations from where they are passing, and then they are monitoring and doing the analytics. So Chronicle uses IoT enabled shipping containers and sensors to give real-time updates on shipping processes. Similarly, ArcTest, 3 I have listed, there are many are there, and all this are coming from the US itself. In United States, they have already deployed, and many are still developing their prototypes. So it develops and builds blockchain-based software for a range of smart connected items, like including voice assistants or similar to what we use Amazon Alexa and all, including voice assistants or wearables and smart TVs. And the company has built several blockchain decentralized applications that connect to IoT devices like Amazon Alexa and Facebook messengers. Okay. So these are some of the case studies that I have shown. Plenty are there, but the people who are working on this particular area, so I suggest them, I'll show some references. Please go through these references, because within a short time, because if I get a time, then I can elaborate you how Ethereum works, how you can create your private blockchain. People who have already used Ethereum, then there is no issue. But the beginners who want to create their own private blockchain and Ethereum, they can download Ethereum, which is open source, and plenty of research materials are available. They can go through that and they can learn how to develop a private blockchain, because public blockchain is not easy, but private blockchain they can develop. They can use some test network like Ringby and Robson, and they can create their own wallet using MetaMask. MetaMask is one such wallet, easily available. You can download, and it acts as a plugin to your Google Chrome. So you can use that. You can create your private network. If Madhu sir gives further in any other lecture, then I'll try to take hands-on on Ethereum, how to create your private blockchain and how to validate your transactions, how wallet is created. I'm very happy to discuss that hands-on, because now everything I'm telling theoretically, just to give a general idea what is happening, what is actually happening around the world as far as the blockchain and whether blockchain to be used in IoT. So many limitations are there as far as the processing, the communication, the computation capabilities are there, because these sensing devices, they are resource constrained. You can't use directly into the blockchain, so a lot of trade-offs are there. But somehow the researchers have opened the door and they have given a chance to think about it, that you can use blockchain for your IoT infrastructure, but some limitations are there, but we can use it. Some in the US, they have started using it, and the most common prototype that I've shown, that edge chain one, the people have started using that in most of the infrastructure. But one point is clear, that IoT infrastructure using blockchain, go for private blockchain, consensus mechanism that I've shown. But even if you don't want to use those consensus mechanism, better you go for IoT, which is specifically designed for IoT infrastructure itself. So you can use that. So let me conclude. As I mentioned that I've been given the opportunity to share my views. I am also totally new to this blockchain. During the last 6 months, or I've started using blockchain. I myself created my own blockchain network using Ethereum, and a lot of issues are there. Once you start doing hands-on, then you'll learn plenty of things. Okay, so I started with Ethereum, and I've created my own wallet, purchased some methods, and started working on some small prototypes. And I'll try to learn more, because as a teacher, we are all learners. If you are a teacher, means you are bound to learn. And obviously, when you are in computer science, all electronics, so you have to keep that pace, what is happening in the technology environment. Okay. So blockchain will take pace now, because a lot of security and privacy issues are there, and we want that. If people want privacy, people don't trust each other, then they go for blockchain itself. Okay. So let me conclude, because blockchain technology has already made a significant impact in the cryptocurrency applications. And the fundamental building block is nothing but the distributed ledger, the consensus mechanism or the algorithms, and the cryptography, that public key cryptography, that is a backbone for a blockchain technology. And it is promising for IoT and supply chain monitoring applications. In most of the cases, as I have found, that people are using this blockchain IoT where the supply chain is taking place, like supplying the food packets or supplying the medicines or fisheries. There they are using it, okay, because there they are deploying sensors and those transporting materials, and then they are monitoring at different locations. Okay. and every location, because these locations are connected, and everybody sitting at the home, they are monitoring where that packet is and what is the temperature currently at that particular point. So like this, they are monitoring and analyzing the statistics and doing analytics. So that's why distributed ledger, consensus mechanism, and public key cryptography of blockchain technology is promising for IoT, because it provides security to the IoT devices and the IoT infrastructure, and especially for supply chain monitoring applications. And I also mentioned about the architecture. I tried to compare the different architectures that is available or given by the researchers in their research. And the architecture of IoT application, it mapped the functional blocks of the blockchain technology to reveal the challenges that are involved, whether to apply blockchain or not, if you apply, which layer you apply. In the initial stages, I mentioned that you can apply your blockchain directly at the cloud level, but now the trend has changed. You come to one more lower level called fog computing or edge computing. There you deploy your blocks in a form of blockchain. Okay. So nowadays, people are also working on interoperability of the blockchain. Because as I mentioned that if you have Ethereum is one blockchain, if you have a Hyperledger, another blockchain, if you have Coda, another blockchain, then these blockchains, if you connect them, so that connection or intercommunication among the blockchains is called as interoperability. And as far as my knowledge is concerned, there are two such frameworks are there. One is Polkadot, and another is Polkadot network, and another is Cosmos. So in Polkadot network, you can convert your Hyperledger or you transfer your data from Hyperledger to your Ethereum blockchain. Or from Ethereum blockchain, you can transfer your data to another blockchain from different vendor, like Coda. So now the trend has changed. Now they are talking about communication among the blockchains. Now the same thing can be incorporated in IoT applications, and you can come up with a hybrid IoT where your one set of smart home infrastructure application is connected to the transport, smart transport infrastructure through different types of blockchains, and you connect one blockchain with another blockchain. So people who are interested in that, they can Google it, Polkadot network or Cosmos, POLK, Polkadot. So there's a interoperability in blockchain is achieved by this infrastructure, and probably they have a substrate.io. You can Google it, substrate.io. They provide a framework, and they are coming from Web3 Foundation. So this Web3 Foundation, they have developed this concept of interoperability among the blockchain, where one blockchain can communicate with another blockchain. So an Ethereum can communicate with Hyperledger fabric of Linux Foundation. And this is very much required. If you talk about different IoT infrastructures or different applications, you can't restrict yourself to one particular blockchain. Okay, so that's why this interoperability plays an important role, and where you come up with a hybrid IoT protocol, or a framework rather, where your IoT devices will form a pool and connect to one blockchain, another pool of IoT devices from different applications connect to another blockchain, and you connect those blockchains. And we have framework for that like Polkadot or Cosmos. Okay. Generally in Polkadot, they use different types of blockchains as child blockchains, and we call it as a parachain. And every parachain has got their own guidelines, consensus mechanisms and all. And every parachain acts as a blockchain, and they are connected to a relay chain. So I'm talking about Polkadot. That relay chain acts as a grandfather. And they generally use that, they have got their own consensus mechanism and all, and that relay chain, they generally use the grandpa algorithm, and that relay chain actually maintains the global state of entire blockchains. So that is a general idea on which this Polkadot actually works. You can Google it, substrate.io, where you can get the framework of building Polkadot, which talks about interoperability among the blockchains. Okay. And they use the programming language called Rust at one end, and other end they use WASM or WebAssembly. Okay. So similarly, another interoperability mechanism that is provided by Cosmos. So they are also from Web3 Foundation, and this Cosmos, what does? These blockchains are connected using hub and node. For instance, if you have one blockchain by Ethereum, another blockchain by Hyperledger, another by Coda, these blockchains you connect with a hub, and that hub itself is a blockchain. So that's why we have an advantage here, because we are talking about the scalability, is talking about security and all. Then this connectivity among the blockchains, and these blockchains are connected to the different IoT infrastructure, will definitely help you to achieve this scalability and security issues. You can solve this problem. So that's why I've discussed this architecture of IoT applications, where I tried to compare the layers. Okay. So I presented opportunities for applying blockchain for the IoT, where you can apply. I started with applying the blockchain at the cloud level. Then now the prototype has already been developed and work is going on as far as edge chain is concerned, where you are deploying your blockchains at the edge level or fog layer. And I finally conclude that with the challenges which need to be addressed to fully exploit the benefits of blockchain technology in the IoT domain. So a lot of work has to be carried out. A lot of researchers are doing a lot of work, a lot of material or papers are available. You can refer through. So the teachers who are carrying out research in this area, I suggest I'll show the references also to refer to this, and have patience. Try to build your own blockchain, because Madhu sir might have given you hands on session on developing various prototypes on IoT infrastructures and all, how to connect your Raspberry Pi with different types of sensors, and how to connect them with your cloud, and how to using some MQTT protocol and all this taught by Madhu sir, because it takes so many classes in IoT and all. So there he takes the responsibility of laying the strong foundation in this area. And then my last is, despite the challenges, the blockchain technologies are highly promising, resolving security, privacy, and trust issues in multi-stakeholder application environments. Because nowadays, a scenario of decentralization, the stakeholders are not trusting each other. So that's why they are going to use this technology. So thank you so much. If you have any queries, you can ask. Madhu sir?
Hello.
Sir.
Madhu garu.
Sir.
Hello, I'm seeing yes. Srinivas sir here. Srinivas sir. Hello sir, myself Sridhar. How are you, sir?
Yes sir, I'm here.
So how was the talk?
Fine,
It's
sir.
just a general
Fine.
idea I have given.
Thank you. Yeah. So we are very much thankful, Sridhar sir, for giving
Thank you so much, sir.
very good
Thank you so
lecture
much.
on the blockchain architectures and the implementation of blockchain in the
Thank you,
IoT
sir.
environment, which is a very upcoming research area also.
Thank you, sir.
Thank you very much, sir.
So I request all the
spending some time.
I request all the participants who are working in this area, please contact me so that I can help you, I can guide you, because I am also learning now. Because as a teacher, we are all learners. Every day we are learning something.
Yes,
we learn from students
yes,
also.
Yes. Okay. Yes, sir. Yes. Okay,
Madhu,
thank you
sir?
very much, sir.
Thank you, sir. Thanks a lot.
Madhu garu.
Sir.
Sir, any questions?
There was a question from the participant, sir.
Okay.
What is the role of blockchain in 5G or next generation communication?
As I mentioned that in that architecture also I have mentioned that 5G, because 5G is not yet completely coming in, because it takes some time in India, because the processing capabilities will increase now, because the IoTs are the resource content devices, and when 5G comes, then the latency, throughput, they are all improve a lot. Okay, because currently we are using 4G, a lot of issues as far as the bandwidth latency is concerned. If you move one more level, a new level called 5G, then obviously more applications can be applicable, because these features that I mentioned, like latency, throughput, and all, they'll take the place. So it's very much used in that. It will be used, and I don't know whether the applications that I have shown that is already working in US, whether they are using 5G or 4G, that I have not found out. Probably they may be using 5G also.
So there was also a question like how POS and POW differ from?
Proof of work. Proof of work is actually coming from the Bitcoin, okay, Bitcoin blockchain, where the proof of work is nothing but a hash puzzle, cryptographic hash puzzle has to be solved by the miner. Okay, that is nothing but the difficulty level. But when I say proof of stake, stake means each and every miner has to claim their stake that they are more powerful, maybe based on currency or maybe based on their computational capability. Generally, stake means they talk about that I am more wealthier, so I'll create the block first because I have got more money. Okay, so they are claiming their stake, and it has got a lot of issues are there, limitations as far because everybody can claim that I have got more number of currencies, so let me validate this block. So there are both positives and negatives are there. When I say proof of stake means yes, the nodes or the stakeholders are staking claim that they have got more number of bitcoins, so more number of currencies. So give them a chance to validate the transaction or the block. Otherwise, in proof of work, they have to use their entire computational capabilities to solve that hash puzzle. Because finding the value of the hash value is very difficult task. So a lot of computations are required. So that is the difference when I say proof of work and proof of stake. So Bitcoin blockchain uses only proof of work, but Ethereum uses both.
So someone is asking what is the use of blockchain?
Use of?
Blockchain.
Blockchain is used generally for financial transaction and all, where, for instance, I'll give a simple example that I've already given an example at the beginning. So you have got your own bank balances and all because you have a trust on SBI or Bank of Baroda or Andhra Bank, whatever it is. Because you have got a trust, so you have got money in that bank. But there are countries where people doesn't have any belief on the banks, where the military acts as a government. So in that case, people are using blockchain where your entire ledger, where the transaction taking place, are seen each and every one in the network. Okay, so that is transparent. If you have 500 in your account, that 500, whichever bank you have, I can see that. So you assume that the banks are not there. For instance, if you are doing online shopping like Amazon, you are buying something. Okay, so that transaction is taking place through some wallet or through some bank. Some third party is involved. So in blockchain, we don't have a concept of server. We don't have a concept of third party. Everybody is involved in the transaction process. Okay, in the first, this diagram I have shown, the decentralized means, I have shown this, this one you see, this one. The future, the last diagram you see, everybody is connected. There is no central concept. Central authority is not there. There is no server as such. Every node acts as a server, every node acts as a client. So you assume that you are doing online shopping and the bank concepts is not there. The bank is not there at all. Okay, so you want to send some money to your friend, you directly send it through your decentralized network or a blockchain. There is no bank is involved. So when I say decentralized, there is no central authority, there is no server. Whatever the transaction are taking place in the entire network, each and every one can see all those transactions. So once the transaction is made, it can't be changed. So the double spending concept is not there. The double spending is there in Bitcoin. That same coin is sent to 2%, but that is not possible in case of Ethereum. So that is there in Bitcoin. So the double spending is a problem. So there are several consensus mechanisms are there to solve the double spending. So when I say blockchain, think about decentralized environment where we don't talk about client server architecture. There is no concept of client server as such. Every node is a client, every node is a server. So we call it as a distributed ledger. Your transaction is distributed to everyone. Whatever you are doing, everybody knows that. Okay. Similarly, if you know the concept of pair programming in software engineering. So when I say pair programming and egoless programming, if you write a program, that program is visible to everyone. So that is something what you call transparent. Like GitHub also provides the transparency. Madhu sir is writing so many codes and putting in GitHub, accessed by everyone. Okay, so that's why blockchain is nothing but a decentralized ecosystem where the transactions are taking place from one node to another, and everybody can visualize the transaction. Any other questions, sir?
As of now, no, sir. People are asking your PPT, so if you could share me, I will share it to the.
Okay, I'll send you, sir. I'll send you, sir. No problem.
Okay, sir. Thank you.
Now, how many participants are there, sir?
There are 300 plus, but since it is YouTube live, we cannot guarantee that how many have attended. But
Okay,
people are attending.
Okay. Okay, sir. Thanks a lot. Thanks for giving me this opportunity to share my views on this.
Thanks for accepting our invitation too, sir.
Thank you so much. Okay.
Thank you, sir. Thank you very much.
Thank you, sir. Welcome.
So I request all the participants to give the feedback through the link provided to you on the YouTube chat, and as well as the link is also provided through the WhatsApp group. So you have to give the feedback before 6 p.m. today, and this will be considered as your attendance for today also. And tomorrow session starts exactly by 11 o'clock. I request all the participants to be present exactly by 11 o'clock tomorrow morning, and the link will be shared to you. Okay, sir. Madhu, sir.
Okay, sir. Fine, sir.
మీరేమైనా చెప్తారా రేపు దీని గురించి? Small 1 or 2 sentences.
Tomorrow you should be ready with laptop, because from tomorrow onwards we will have hands-on. So today we had some theory sessions, right? So from tomorrow you'll have hands-on. Please make sure that you have laptop or at least an a desktop PC in order to do hands-on on IoT applications. Because as the program is focused on building applications on IoT with agriculture context, so I just want to have you hands-on so that for your research or for your for your application development also it will help you out. So we will be using Google Colab from tomorrow. So anyways, Google Colab will be there with you because if you have Gmail ID, you can easily access Google Colab. So I'll talk about it tomorrow morning at 11. So I'll meet you there with complete hands-on. Thank you.
Okay, Madhu. Thank you. Thank you.
Right, thank you, sir.
Sir, HOD, sir. Sir, HOD garu. Sir, please unmute, sir.
Name. Okay. Sir.
Okay.
Sir. Okay. అయిపోయింది కదా సెషన్?
అయిపోయింది సార్, అయిపోయింది.
ఓకే అండి, క్లోజ్